Welcome everyone, my name is Sagar and in this video we will be continuing with our task number 38, and in our previous video we learnt about linked list and the concept of this node class, and I already gave you one task. This is task 38 and here we have to make our this MyLinkedList class generics. And if you don't know what is a linked list and how we can create our own linked list class, then go watch out our previous video first. And here first of all we have to make our linked list class generics. And if you don't know what is generics and how we can make a class generics, then I will recommend you to watch out our array list video, and there I also told you about this generics concept. So for making this my linked list class generics, I will use this and I will pass here this t. So now I will just use this t inside of this node class, because only inside of this node class we have our integer data type, right? So this is my integer, so I will use here t, and for my one node I will get this t here, okay, and also here. So I think now that's it. So this is our node class, and now this node class is a generic type. And for our linked list class, so I will just pass this t here. So I am passing this t from my linked list class to my node class, okay, and also t here. And instead of getting here integer, so I will get a t data type that I am passing to create my this linked list class, okay. And while I am creating a node, so I will create a node of type t, and also here. So I will just use here this diamond operator, and I don't have to define here this t type, okay. So I already told you about all these things in our previous video. So first of all, go watch out our array list video. And what is this? Okay, we have to define here this t. So now everything will work fine. And also we are returning here integer, but instead we have to return here a t. So now let's just create a linked list class of type string. So previously we created a linked list class of type integer, but now we will create a string type because we are using a generics. So I will just make all of them as strings, and I think now it should work. So let me just check if this is working. Then all of these type are string, and our first task is done. Okay, as you can see, it is working, and why it is showing false? Because our linked list is not empty. Okay, so our first task is done, and after that our second task is to create an add and remove method that takes two params, that is index and element. So let's just create a method here. So first of all we have to add a method, so that means it will be just a word function and add. So we are adding two functions with the same name, but we have to add here different parameters. So what is this code? Let me know in the comment section. It is method overloading or it is method overriding. Okay, we will pass here first of all an index and then this t value. And so what we have to do, we have to add here any method, add here any value at a particular index, okay. So let me just show you that on whiteboard. So here we will have our node here. So this is our node. So suppose these are our nodes, and let me just make a path here. So from here like this, okay. So first, so this is our 0 index, this is 1, this is 2, this is 3. So suppose we are to add an element at a 2 index. So what we have to do is we have to add here a new node. So this will be our 2 index, and now this should be 3 and this should be 4. So 3 will be here and 4 will be here, and that means from our 1 index we have to change the next value of our 1, right? So from 1 we have to change the next, and that means where is the index? So we have to change the second index, right? So that means we have to change the next of our first index. So we have to move till the first. So from the next of our first, so this is our first, that means the index minus 1, right? So we have to be first here. So suppose there is some temp, and that will be at this index minus 1, because our index is 2 and we will be at index minus 1, right? So our temp is at index minus 1 and we have to change the next value. So previously the next value was this, but now we have to add a new element, that means we have to change the next value. So the next value will be this new value that we are going to create. So this will be a new node, and for this new node the next value will be this one, the previous one, okay. So this is how we can create our flow of linked list. Okay, so the task is to, okay, so first of all we have to create this new node. So let's just create a node of type T, new node, and we have to pass this value here. So this is our new node, and let me just write here new node. And suppose the index value is 2. So suppose the index is 2, so here it is 2, and our head is currently pointing to this, so head. And I already told you, so it is not head, it is first. So I already told you in our previous video that we cannot directly move our first value. We cannot directly move our first node. We have to create a temporary. We have to move our temporary reference, because if we are moving in forward direction, then we cannot move to our backward. So we will just lose the reference to our all these nodes. So that's why we cannot move our first, and we have to create a temp. So let's just create a temp that will be initially at this. So temp will be here, and we have to move our temp until this thing. So this is index -1. So our index is 2, and we have to move our temp to this index -1. So let's just create a temp of type T, and this will be initially first. And we also have to check our base cases before doing all these things, and I will also show you that. So first of all, here you can see our temp is currently pointing to this first node, and we have to add a new node at a 2 index. So what we have to do, we have to move our temp to our 2 minus 1 1. Okay, so our temp will be here, and you know how we can move a node inside of our linked list. So we have to run a loop. I should be less than index -1, I plus plus. So I is 0 and I should be less than, so suppose the index value is 2. So 2 minus 1 is 1. So I should be less than 1, and that means I should be 0. So we will only move one time. Okay. So temp equal to temp dot next. So temp is initially at this 0 index. So temp equal to temp dot next. That means temp will just move ahead, and temp will be here. So temp is at 1. Okay. And now you can see temp is here, and the next of temp is this ahead. Okay, so this is our further linked list. Okay, what we have to do is we have to store the reference to this node. But if you are not storing this, and you are just directly saying this equal to this now, so you will just lose the reference to this further linked list. Okay, and let me just do it. So if we are just doing this thing, so our temp is at here, and what we have to do is this temp dot next is pointing to this further linked list. But what we have to do, we have to point to this new node. So this is our temp, and temp dot next should point to this new node. So I will just do it. Temp dot next should point to this new node, and that's it. So temp.next will not point to this further linked list, and now temp.next will point to this new node. But now we just lost the reference to our whole further linked list. As you can see, there is nothing that is pointing to this linked list node. Okay, so that's why we have to first store this before changing the next pointer. Okay, and this is one of the most important thing that you have to remember, that you don't have to lose the reference to any node in the linked list. Okay, so first of all, before changing any reference, so we are changing here the next value, and before changing the next value, first of all we have to store this reference. Okay, so here we are changing, and this equal to means that we are assigning a new value, and before assigning a new value, first of all we have to store this temp dot next. So node of type T ahead linked list. So this is our further linked list. Okay, let me just write here further linked list. So this is our further linked list node, and this will point to our whole linked list after this node. Okay, and currently we are just pointing to this. So our node is currently pointing to this node, and we have to change this thing. Okay, we have to change this correction. So before changing, we have to store this thing. Temp dot next. So as you can see now, so we are gonna change our temp dot next, and before changing, we are storing it. So we are storing this temp dot next inside of this further linked list. So this will be now stored here. So further linked list. So this is our variable that is pointing to this, and we have the reference to this further linked list. Okay, and now we have this temp. So we are going to change this temp dot next. So temp dot next will be this new node. Okay, and after that, what we have to do, new node dot next equal to this further linked list. So that's it. So new node dot next equal to this further linked list. So now this new node dot next equal to this node, and now you can see we just added an element inside of at an index inside of our linked list. So you can see, so this is our second index, and we just added element inside of our linked list. Okay, so this is how you can work, and at last you can either return true or false if it is added or if it is not. But there is a major problem now, and suppose I have to add element at 100 index. So how can we add element at 100 index? Because the size of our linked list is just 4. So we just get the size of our linked list. We can just create a variable here. So suppose long, or we can just say int size. And when we are adding our element, we can just say size plus plus, and we don't have any function to remove our element, and we can just do here is size equal to 0. So if our size is 0, then our list is empty, and it is not. So if we are adding any element, then I am increasing the size, and let me just check here. If our index is greater than or equal to our size. So if our elements are only 3, 1, 2, 3. So 1, 2, 3, and the index will be 0, 1, 2. And what I am saying is I have to add an element at third index. So what we can do is either we can also add an element at third index, and that's totally up to you how you want to design. So I will just not say equal to. So if the maximum index possible inside of our linked list is 2, and I want to add an element at index 3, so we can also do that. But suppose I am saying that we have to add an element at 30th index, so we can do it. So we can just return here false, and we have to make it a boolean. Boolean. So after this, we can just return here true. So that's it. So this is our add function, and we can just design our delete function, our remove function from any index with the same way. But there is also one base case remaining. But if I have to add element at 0 index, so how can we do this? So let me just remove it first. So suppose there is a new node, and our head is currently pointing to this, and we have to move till our head minus 1, that means index minus 1. So if our index is already given 0, then how we can move to index minus 1? So it is not possible, right? So our head is also pointing to this, and our temp is also pointing to this. So how we can add an element at our head? So if so, this will be considered as our base case. So just remember all these base cases, or you can also say edge case, because this is our normal linked list class. So this will be our edge case that you also have to remember always. So always try to think about all the base cases that you have in your DSA problems. So if we have to add element at our 0 index, then what we have to do? We have to create our new node, the new head. So our head will also point to this, and our temp will not point to anywhere, because our temp is just temporary. Okay. So our new head will be just this, and this will be our new head. So what we can do is this new head dot next will be equal to this previous head. So before changing the reference to this, we also have to store it. So if our index equal to 0, so then this will be a special case. Okay. So let me just create here. So suppose this is our linked list or linked list. Okay. And our head is currently pointing to this, and this is our new node. Okay. And so what we have to do? We have to change our head, and our head will be this. So our new head will be this new node. So after creating this new node, okay, I will write here this base case. So after creating this new node, if our index is 0, then I have to change my head. So our head will be equal to our head, or our head is considered as this first node. Okay. So our first node will be equal to this new node, and now you can see our head is our head or our first node. So our first node is pointing to this new node, and after that we just lost the reference to this. We just lost the reference to our this linked list. So what we can do is before changing the first, we can just store it. So node this of type T further linked list. So as we are also doing here, before changing, we are storing the reference. So this is the exact same that we have to do here. So further linked list will be this first, and after that we are changing our first to our new node, and I have to do the same thing. New node dot next value will be equal to this further linked list. That's it. So and after that I will also return here true. So that's it. First of all, what we are doing here is we are just changing our first value to this new, and after that we have to change this new to this original linked list. Okay, so new node dot next will be equal to our original linked list. Okay, so that's why we have to store it before changing it. So always remember this thing, that you don't have to lose the reference to any node inside of your linked list. So now you can just implement this remove method by yourself. It will be almost similar to this add method. The iteration is exact similar. You have to just do this thing, temp equal to temp dot next, and always remember that you have to always create a temp node, because you don't have to move your main node, or you can say head node, because you cannot move back. So here when we are adding a node, so we are just doing this thing. We are creating a new node object. Here we are creating a new node object, and what we are doing, we are moving our temp, and after that we are also storing the reference to our further linked list. So after storing this reference, we are just adding a new node inside of this middle of our original linked list. So temp dot next equal to our new node, and our new node dot next equal to our further linked list. So that is how we are adding a new node. But when we have to remove a new node, or when we have to remove existing node, so suppose this is our linked list, and it is pointing to this, and this is pointing to this. So we have to remove this node. So how can we do this? So suppose this is our temp, so our temp is at our existing node, our target node that we have to remove, -1. So our temp should be here, and that is obvious. If we have to remove our head node, so we can just do head will be equal to this, so we can just remove our head node like this. Okay, so our temp node is at this point, and we have to remove this node. So what we can do, so we have to remove this node, so we have to say that this node dot next will now not point to this. So that means the next pointer to this node should point to this. So this is the next dot next. So we just have to do this thing. Let me just write this thing in code. So what we have to do, so suppose this is our temp value, and we have to remove our temp dot next. So we have to remove temp dot next. So that means we should lose the reference to our temp dot next, and you can see currently this is our temp dot next. As you can see here, this is our temp, and temp dot next is this node, but temp dot next. So let me just write here, temp dot next. So temp dot next is this, and what is the next node of this node? So next node is this. So temp dot next is this node. Okay, so what we have to do, temp dot next. So the next value from this temp should be this node. So what we have to do, so we just have to write this thing, that temp, so this is the temp dot next value. So temp dot next value will be, so temp dot next value will be this node, and you can see this node is temp dot next. So I hope this thing is not that much confusing to you, but if you are doing this first time, then you might get confused. So just take your time to consume this thing, that how we are doing this thing, temp dot next. That means we are changing the reference to the next value of our temp, and temp dot next is a node. Okay, so this temp dot next is this node, and we are just changing the reference to this temp dot next. Okay, so I hope now you understand this thing. And now temp dot next will not point to this, and the temp dot next value will be updated after this. So temp dot next will be updated, and it will be this. Okay, so we just so this node will be also pointing to this, but we don't have the reference to this node, so we will just lose it, and we will not consider as a part of our linked list. So our linked list flow will be from this. Okay, so that is how you can just remove a node from our linked list, and after that you can just implement your method here. And also I will recommend you to go to our LeetCode platform and search for design linked list LeetCode. So this is a question on our LeetCode platform that you can practice, and you can just implement this exact same thing on our LeetCode, and you can just try some base cases. So here is our problem statement. So just read this thing first. So you have to design your implementation of linked list, that we already did here. So this is our linked list class, that is also generic, and also in this we have pointer to two nodes, first and last, and that is totally your choice, that you want the pointer to your last node or not. And in this case, in our linked list class, we never need this thing, so we can also remove this, or let me not remove it. Okay, so
So in this problem, so first read this thing out, and there are a lot of methods that we have to implement here, and we almost implemented all methods in our linked list class. So first of all, this is our constructor and this is our linked list class, but we have to implement our node class also here. So just create a node class here, and this is our constructor. There we can initialize our linked list object, or inside of this, so in our constructor of this linked list class we are doing nothing. So you can also keep this constructor as it is, and after that we have this get method and we are passing there an index, and we also have the same thing here. So we have this get method, so we already implemented this, and after that we have this add at head. So we already handled this base case already inside of this. So this is our add. Okay, this is not at index. So this is our add method, that adds any element at particular index, and if our index is 0, so this is our base case that we are already handling. So this is the base case where we are adding any element at head. So this is a particular method inside of this. So you can also implement this by yourself, and there is also a method to add at tail. So you can just use this last reference for this method. Okay, and after that we also have this add at index. So this is the exact same method here, and all these are void methods here, remember that thing. And also we have this delete at index. So there is only one method that use deletion, so you can just use this concept now. So this concept temp.next equal to temp.next.next. So that means we are just ignoring the reference to our middle element, and also remember the base case that temp.next.next can be also null. So let me just show you the base case. So the base case can be that temp is the last node. So temp.next will be null, and this will just throw us a null pointer exception. Okay. So if there is only one node in our linked list, so this can be a base case that you also have to handle separately. So suppose this is our node inside of our linked list, and this is our only node, and the next value of this will be null. So this is our temp, and this is also our head. But what if we have to remove the value of index 1? So this will be at index 0 and this will be at index 1. So you also have to check this thing that there should be a valid index. And if we are just following our code temp.next, so temp.next will be this, and this is here null temp.next. And when we are trying to access this temp.next, so we cannot access the next value of null. So this will just throw us a null pointer exception, because what we are trying is temp.next is null, and we are trying to access the next probability of a null object. So this is not possible. So that's why we will get a null pointer exception. So always remember to handle all the base cases also. I hope now you understand the task, and you can implement this remove method, and you can also solve the problem on LeetCode. So that is it for today, and if you understand this concept today, then do hit the like button and also subscribe to our channel if you want more such content. So thank you for watching.